Welcome to KEAM 2023 Crash Course. Well, today we are going to revise 3D Geometry chapter because as you all know, vectors in 3D are very important chapters because a lot of questions are asked every year, right? So we will be today revising the entire chapter with all the formulas that you need along with all the previous year questions asked, different type questions that were asked. We'll practice them. I am also going to make a complete mind map and formula cheat sheet of the entire chapter today itself for you. So yes, if you watch this video, 3D geometry is confirmed for you that you will be able to solve each and every question, guaranteed. Okay, so quickly subscribe to this channel if you want to prepare for KEAM 2023 in the minimal time possible with the best notes also. All right guys, so quickly subscribe to this channel and yeah, don't forget to hit the like button and mark your attendance. Okay, so basically from this chapter every year 8 to 9 questions are asked and it constitutes around 32 to 36 marks. Quite a big weightage, right? So it is super important and definitely asked every year. So also, the good thing is it is absolutely formula based. No logic, no extra explanation required. Just apply the formula, get the answer. That's what we want, right? So, let's learn about each and every topic. I will also show you the basics and the formulas one by one. Okay, now starting with direction cosines and direction ratios of a line. So, even in the past year also one question was asked from this topic. Now it is very simple. Direction cosine is basically if you are representing a point or a line in a 3D space. Okay, now in the 3D space you will have x-axis, y-axis, z-axis. The line will make basically some angle with the 3 axis. Suppose it is making angle alpha, angle beta, angle gamma with x and y and z axis. So the cos of angle alpha, cos of angle beta and cos of angle gamma is called as cosines. Basically direction cosines of that line. Okay, now this direction cosine is also represented as cos alpha is represented as L, cos beta is represented as M and cos gamma is represented as N. Okay, so you might see L, M, N terms also written somewhere in the question paper. Now there is one very important formula based on this, that L square plus M square plus N square is always equal to 1. So note down this formula number 1 related to direction cosines. Okay, now after this it's important to remember that any line or a vector which is parallel, they will always have same direction cosines. They will always have same direction cosines. Okay, so if you have two parallel lines, line AB and line L, so the direction cosines of this line and direction cosines of this line will be absolutely same. This is also important to remember. Okay, now let's do one quick question based on this. If a line makes an angle 90 degree and 60 degree with the positive direction of x-axis and y-axis, find the angle which it makes with the positive direction of z-axis. What they are trying to say is cos alpha is 90 degree basically, not cos alpha is 90 degree, alpha is 90 degree, right? So alpha is 90 degree, hai na? So cos alpha will be how much? Cos alpha will be cos 90 degree. Cos 90 degree is 0. Similarly, beta is 60 degree. So cos beta will be cos 60 degree. Cos 60 degree is 1 by 2. So this is L, this is M. And cos gamma is unknown. So we will simply write it as N. Now we know an important formula we have learned just now. L square plus M square plus N square is equal to 1. So here we have 0 plus 1 by 2 whole square plus N square is equal to 1. So N square will be equal to 1 minus 1 by 4. So N will be equal to root 3 by 4. So this is nothing but plus minus root 3 by 2. Now N value is root 3 by 2, but we know that what is N? n is cos gamma, right? So if cos gamma is root 3 by 2 or minus root 3 by 2, then basically gamma is 30 degree or 150 degree, right? Okay, now let's learn about direction ratio. Now direction ratio is very much related to direction cosines. Suppose that you have a vector where along the x-axis, y-axis and z-axis the respective components are a, I cap, b, j cap, c, k cap. Okay, so here the vector is ai plus bj plus zk. Then the direction ratios of this vector will be a, b and c. Okay, similarly, if your vector is basically formed by joining 2 points x1, y1, z1, x2, y2, z2. So your vector equation will be what? It will be simply x2 minus x1 I cap, y2 minus y1 j cap and z2 minus z1 k cap, right? So direction ratios here will be x2 minus x1, y2 minus y1, z2 minus z1. These will be your direction ratios. Okay. Now, as if we compare the two, that if your direction ratio is in vector form or direction ratio is in Cartesian form, we can clearly say that in Cartesian form, the direction ratios are x2 minus x1, y2 minus y1, z2 minus z1, which is equivalent to having a vector with a vector, b vector and c component along the I, j and k, that is x, y and z axis. Okay. So in vector form, it will be ABC. In Cartesian form, it will be x2 minus x1, y2 minus y1, z2 minus z1. What is ABC? Some constant value, 1, 2, 3, 4, like that. Okay. Now, what is the relationship between direction ratios and direction cosines? Now, every direction cosine L, M and N can be obtained with the help of this formula. So, L is basically plus minus A upon root over A square plus B square plus C square. M is plus minus B upon root over A square plus B square plus C square, and N is plus minus C upon root over A square plus B square plus C square. Now, what is plus and minus? Plus is basically positive direction of x-axis, y-axis, z-axis, and this is negative direction of x-axis, y-axis, z-axis. Simple. Okay. Now, so till now we have learned what are direction cosines and direction ratios. Now let's learn about representing a line in a three-dimensional space. Now how can you represent a line in a 3D space? Suppose you have x-axis, y-axis, z-axis and there is a line. Now this line can be denoted with the help of a point on it and a parallel vector. Why? Because this parallel vector and this line will have same direction cosines. Similarly, either like this, or you can represent the line with the help of 2 points, because 2 points A and B will obviously define the line. So there are two methods. First is either a point is given and a parallel vector is given, or 2 points are given. Okay. So first is, if there is a line L, we know a point A and a parallel vector B, parallel to that line, then the equation of line in vector form will be R is equal to A plus lambda B, where R is basically denoting any point on the line, A is the given point on the line, B is the parallel vector of the line, okay, and lambda is any constant value. Okay. Now similarly in the Cartesian form, once again you will have the point, but this time the point is not in vector form, it is in Cartesian form. x1, y1, z1 is the coordinate of the point and the vector will be the parallel vector. So here in the Cartesian form, this parallel vector will have some direction ratios, ai, bj, ck, like that. So the equation of the line will be x minus x1 is equal to y minus y1 is equal to z minus z1 upon lmn. You can also write it as x minus x1. What is x1, y1, z1? Coordinate of the point on the line. Okay. X minus x1 upon a, y minus y1 upon b, z minus z1 upon c. Both are Same. Either ABC or LMN. Anything you can write. Now what is ABC? The parallel vector, direction cosines. Okay. Now what will happen when 2 points are given? Simple. So if you have 2 points, one point is A, one point is B. Okay. And again you have a parallel vector. No, you don't need a parallel vector now because now you have 2 points now, so you don't need a parallel vector. So your equation of line will be what? See, if you want to get direction cosines of the line, you can simply do what? I told you na, ABC is equivalent to the 2-point different x2 minus x1, y2 minus y1, z2 minus z1, right? So here this point B is having vector B, point A is having vector A because we are learning vector form representation. So the formula will be R will be A plus lambda times of B minus A. So suppose your A vector is given 3i 4j plus 3k and your B vector is given 4i 2k 2j 1k, anything. Okay, so just put it in the formula A plus lambda times of B minus A. Lambda will be lambda, no value to lambda. Okay, so this is equation in vector form when 2 points are given. Okay, so just put first point here and difference of the 2 points here. Okay, now similarly in Cartesian form same thing will happen. Now what will happen? A, B, C will become x2 minus x1, y2 minus y1, z2 minus z1. So your formula will become x up minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay, so here is the complete formula sheet for you in Cartesian form, in vector form, in when 1 point is given, when 2 points is given. Okay, so when 1 point is given, it will be A, B, C. When 2 points are given, it will be x2 minus x1, y2 minus y1, z2 minus z1. Right? Here also, when 1 point is given, simply the parallel vector. When 2 points is given, difference of the 2 points. That's the only difference. Okay. Now, let's do some questions. Find the vector equation of a line which passes through 2 given points. So, how do we write the vector equation? Vector equation is first point plus lambda times of difference of the 2 points. So, take the first point as 3i cap 4j cap minus 7k cap, right? This is the first point plus lambda times of B minus A. B minus A will be, this is B, this is A. So, 1 minus 3 I cap, then minus 1 minus 4 j cap and 6 minus minus 7 k cap. So, this will be basically R vector will be A vector 3i 4j 7k plus lambda times of 1 minus 3 is minus 2i minus 5j and 6 plus 7 is 13k. So, this is the equation of the line. Got it everybody? This is your final answer. Okay. Next is find the Cartesian equation of the line which passes through this point. Point is given and parallel to line. Now here parallel vector is not given, parallel line is given. So what we will do? I told you at the beginning, parallel lines have same direction cosine. So here it will be A, this will be B, this will be C. So we have parallel vector also. So simply what is the equation of the line? Equation of the line is x minus x1 upon A, y minus y1 upon B, z minus z1 upon C. So here x minus, what is x1? Minus 2 upon 3, y minus 4 upon 5, z minus minus 5 upon 6. है ना? This is A, B, C. That's it. This is the equation of the line. You can also write it as minus of minus 2 plus 2. Similarly, minus of minus 5 plus 5. You can also write it like this. That's it, nothing else. Okay, understood everybody? Equation of line is also asked in question paper, so you should know. Okay, now next is how to find out angle between two lines. Now if you have two lines, you will have their direction ratio a1 b1 c1, a2 b2 c2. So the angle between them is theta is cos inverse of mod value of, remember mod value because we need positive answers only. Okay, so a1 into a2 plus b1 into b2 plus c1 into c2 upon root over a1 square b1 square c1 square into root over a2 square plus b2 square plus c2 square. Okay, so this is angle between two lines formula. Remember it is cos theta. Okay, next, similarly if direction ratio is not given, direction cosine is given, then it will be theta will be cos inverse of L1 into L2 plus M1 into N2 plus N1 into N2. Now you might be wondering in the denominator why we don't have L1 square plus M1 square plus N1 square, because remember L square plus M square plus N square is equal to 1. So this will become 1 and no need to write 1. So therefore it is not mentioned in the formula itself. This is just the formula. Okay, so this is angle between two lines. Next, if your lines are perpendicular, if you know that the lines are making angle 90 degree, then put it in the formula. Cos 90 is 0. So a1 into a2, b1 into b2 plus c1 into c2 will be 0. Similarly, if your lines are parallel, so if the lines are parallel, the angle between them will be 0. Cos 0 is 1. So here a1 upon a2 will be equal to b1 upon b2 is equal to c1 upon c2. Okay. So remember these two formula. Again questions are asked based on them. Okay. All the formulas are important. No formula is like not asked in the question paper. Next, find the value of lambda so that these two lines are at right angle. So what have we learned? If they are at right angles, then what happens? A1 into A2, B1 into B2, C1 into C2 is equal to 0. Right? Just now we have seen the formula here. So let us put this is A1, B1, C1. A1, B1, C1. This is A2, B2, C2. Just put it in the formula. So you have 3 into 3 lambda plus lambda into 1 plus 2 into 5 is equal to 0. 9 lambda plus 10 is equal to 0. 10 lambda is equal to minus 10. So lambda is equal to minus 1. That's it. This can definitely come in your exam for, of course, MCQ type questions. है ना? Lambda is minus 1, 2, 3, 4. Definitely it can come. Okay. Next is how to find out distance between two lines in a 3D space. Okay. First, if your lines are intersecting, if they intersect, distance is of course 0 because they are passing through each other. There is no distance. If your lines are parallel, then they will have a shortest distance between them, which will be the perpendicular distance. But if they are skew lines, now what are skew lines? In your three-dimensional space, if one line is going like this, another line is going like this, are they parallel? No. Are they intersecting? No. So these lines are called as skew lines, and skew lines also have distance between them. What is the formula? First, if your lines are parallel, so suppose your line number 1 is A1 plus lambda b, line number 2 is A2 plus mu b. Now you are wondering why it is B and B, not B1, B2, because remember parallel lines have same direction cosine, same parallel vector, that's why. So the distance between them is cross product of B with A2 minus A1 upon mod B. Okay. Now if they are skew lines means they are not parallel. So here B1 and B2 will be different and therefore it will be cross product of B1 and B2, then difference of A2 minus A1, then dot product, here it is dot product divided by b1 cross b2 mod value. Okay, this is the shortest distance formula. Now this is generally not asked. I have observed that distance formula is not asked, maybe because it is too lengthy. This is very lengthy to solve, and you know that for every question you have 1.5 minutes, 2 minutes. So this type of question is very lengthy. It can't be done in 2 minutes. Generally it is not asked, but still you should know the formula. Maybe it will be asked. Now similarly, if your lines are skew lines and you have Cartesian form, so Cartesian form will have this formula: determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 upon this. I am quite what can I say? I can't say I'm very sure, but yeah, I'm like 80% sure that this formula will not be asked in the question paper. It's very lengthy. Okay. Next is, what will happen if the lines are intersecting? Just now we have seen that the distance between them will be 0. So if the distance is 0, this implies that b1 cross b2 dot a2 minus a1 will be 0 and this numerator will be 0. So in the vector form, this will happen. In the Cartesian form, numerator will be 0. Okay, if they are intersecting, right? Now, let's come to planes. Planes are very important. More number of questions are asked from planes rather than lines. Okay, so let's see all the formula for planes as well. Formula number 1. The general equation of a plane in a 3D space is ax plus by plus cz plus d is equal to 0, where a, b, c are the constants not equal to 0. Okay, now if your plane is passing through origin, then d will become 0 and equation will be ax plus by plus cz only. And if your plane is passing through a given point x1, y1, z1, then your equation will be a into x minus x1, b into y minus y1, c into z minus z1. Where is d? D is here only. You will get d when you open the brackets and simplify. So these are the 3 formulas for equation of a plane. Okay, equation of a plane. A into x minus x1, b into y minus y1, c into z minus z1. This is most important. Next, what will happen if you have lmn as the direction cosine of a normal to the plane? P is the perpendicular distance of the plane from the origin. Then the equation of the plane will be, if you have the direction cosines element, so it will be Lx, My and Z is equal to P. What is P? P is the distance from the origin. Okay. And if they say that the plane is making intercepts on the XYZ axis, then the equation of the plane will be x upon A plus y upon B plus z upon C is equal to 1. Okay. This is, till now we are only doing equations of plane. Next, if your plane is having 3 points basically, it is passing through 3 points. So equation of plane passing through 3 points x1, y1, z1, x2, y2, z2, x3, y3, z3 given by determinant of x minus, remember here it is x, y, z, don't put any value here. Okay, x minus x1, y minus y1, z minus z1, then x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. So here basically you have z1, 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 y1, 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 x1, 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 only x, x2, x3, like that it will change. Okay, so this is equation of the plane passing through 3 points. Next, distance of a plane from a point asked in the question paper. If there is a point and there is a plane, what is the distance between them? So it will be a into x1. Now what is a? If your plane is of this form, this is your plane, yeah? Ax plus by plus cz plus d is equal to 0. So here in the place of x, y, z, you will put the points, the point for which you are finding the distance. So it will be a into x1, b into y1, c into z1 plus d upon root over a square plus b square plus c square. Okay. Now distance between two parallel planes will be simply difference of their d1 and d2 upon a square root over a square plus b square plus c square. Okay. Now if the two planes are intersecting, suppose if you have two planes, this and this, they represent two different planes, then the equation of the plane passing through the intersection of these two planes, new plane passing through the intersection of these two planes will be first plane plus lambda times of second plane equals to 0. So simple. Okay. And lastly, the angle between two planes is once again cos theta. Cos theta value is mod value of a1 into a2 plus b1 into b2 plus c1 into c2 upon root over a1 square plus b1 square plus c1 square root over a2 square plus b2 square plus c2 square. Okay, understood? So this is angle between the two planes. Clear to everybody? Now, are you guys ready for solving the previous year question paper questions? Let's do it. Question number 1. The direction cosines of this vector are dash. They are asking about direction cosines. Now, we know that this is A, this is B, this is C. Now, how do we find out cosines? Cosines are L, M, N. L value will be plus, since they have not mentioned, we will take positive value only. Okay. A upon root over A square plus B square plus C square. So, 1 upon root over 1 square plus 5 square plus 8 square. So, this will be 1 upon root over 1 plus 25 plus 64. What are we getting? 5 plus 4, 9 plus 1, 10. So we get 0. Then 7, 8, 9 plus 10, 100. So root over 100 is 10 basically. So we get 1 by 10. Now similarly, m value will be b upon a square plus b square plus c square. So it will be minus 5 upon 10, and n value will be 8 upon 10. So which option is correct? We are getting 3 to 10. Have I calculated something wrong? 1 plus 25 plus 64. Yeah. And we have 64 plus 26. Oh, 26. Sorry, my bad. So it will be 5 plus 4, 9 plus 1, 10 and 7, 8, 9, 90. Oh, this is not 100. This is coming 90. Square root of 90 is 9. 9 into 10 is basically 3 root 10, because 9 square root is 3. So it will be 3 root 10, not 10. 3 root 10, 3 root 10 and 3 root 10. Okay. So we have 1 minus 5 and 8. 1 minus 5 and 8 upon 3 root 10. Clear? How to find out direction cosines? Next, if this vector and this vector is given, theta is the angle between them, then find out tan theta. Now you will say, ma'am, you told the formula for cos theta. What we will do about tan theta? So first of all, let us calculate cos theta only. Cos theta is mod value of a1 into a2, b1 into b2, c1 into c2 upon root over a1 square, b1 square, c1 square, a2 square, b2 square, c2 square. What we will get? Let's multiply first. 1 into 2, 2. 1 into 3, 3. 1 into 1. Minus 1 into 1, minus 1. Right? Mod value upon upon root over 1 square plus 1 square plus 1 square root over 2 square plus 3 square plus 1 square. So we are getting here 2 plus 3, 5. 5 minus 1, 4. 4 upon root 3 into 2 2s are 4, 3 3s are 9. 4 plus 9 plus 1 is 14. So root over 14. Now root over 14 into root over 3 will be 4 3 is a 12, 3 1 3 42. Root over 42. So it will become 4 upon space problem. 4 upon root over 42. But this is cos theta value. We need tan theta value. Let me show how do you calculate tan theta value. There is no space. I will write it out here only. Now, if you know cos theta, you can calculate sin theta. How come? See, sin theta is 1 minus cos square theta square root. So, square root of 1 minus 4 upon root over 42 whole square. So, this is square root of 1 minus 16 upon 42. 42 minus 16 is 42, 16 is 6, 3, 26. So, it is root over 26 upon root over 42. Okay. So, this is sin theta value. Root over 26 upon root over 42. Now, you want tan theta value. So, tan theta is sin theta upon cos theta. Sin theta is root over 26 upon root over 42. Cos theta is 4 upon 42. This cancel. Your answer is root over 26 upon 4. Which option is right? Option B, root over 26 upon 4. Remember? Okay. Chal. Next, what will be the value of lambda so that these two vectors are perpendicular? We have just now seen perpendicular formula is a1 into a2 plus b1 into b2 plus c1 into c2 will be 0. So here 2 into 3, 2 into 3 minus 1 into 2 lambda, minus 1 into 2 lambda k, but there is no term of k, so no need to multiply, is equal to 0. So 3 2s are 6 minus 2 lambda is 0. 6 is equal to 2 lambda. Lambda is equal to 3. So your answer is 3. Simple. Next question. Which of the following points lies on the straight line x minus 1 by 2, y plus 1 by 4, z minus 2, z minus 2 by minus 2. Now for this equation, there is a simple shortcut that you pick up all the points and you put it and you find out whether it is lying on the line or not. Okay. So, for example, if you take 2, 6 minus 2, what will happen? So, our equation is this. You are picking 2, 6 minus 2. So, it will be 2, 6 minus 2. Is it coming equal? 2 minus 1 by 2 is 1 by 2. This is 7 by 4 and this is minus 4 upon minus 2. This is not coming correct. Erase. Now I am picking this 330. Let's put 330. So 3 minus 1, 3 plus 1 and 0 minus 2 by minus 2. So 3 minus 1 by 2, 2 by 2. 3 plus 1 by 2, 4 by 4. 0 minus 2 by 2, minus 2 by minus 2. Now this is 1, 1, 1. Is it equal? Yes. So therefore, option D is the right answer. So you have to put the point, pick the point, put it in the formula, put it in the equation and see whether it is coming equal or not. That's the method. Okay. Next, the Cartesian equation of the line passing through these 2 points. So simple, direct formula based question. 2 points are given. So your equation will be x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. X minus x1 is x minus 1 upon 7 minus 1. Y minus minus 1 upon 0 minus minus 1. Z minus 2 upon 5 minus 2. So our equation is x minus 1 upon 6 y plus 1 upon 1, z minus 2 upon 3. 613, where we are getting here x minus 1, y plus 1, z minus 2. See, same equation, this and this, we got the answer. Okay. What is the angle between these two pair of lines? How to find out angle between two lines? Simple. Cos theta is equal to mod value of a1 a2 b1 b2 c1 c2 upon root over a1 square b1 square c1 square a2 square b2 square c2 square. So a1 into a2 is 2 into minus 1 minus 2. 5 into 8, 40, 3 into 4, 12, mod value upon root over 2 square plus 5 square plus 3 square root over 1 square plus 8 square plus 4 square. What do we get? So here we are getting 40 minus 14. So 40 minus 14 will be 6, 3, 26. So this is 26 upon 2 2s are 4, 5 5s are 25, 3 3s are 9. So we are getting here 25 plus 4, 29, 29, 9, 38. So root over 38 into root over 1 plus 64 plus 16. So this is 6 plus 4, 10 plus 1, 11, 7, 8, 81. Root over 81 is 9. So here we are getting root over 81. So my answer should be 26 upon 9 into root over 38. Let's see. Yes. Option E. 26 upon 9 into root over 38. Cos inverse, of course, because we want theta. Next, a plane passes through this point and has a normal vector. Its equation will be dash. How do you find out the equation? Super simple. You just have to do A x minus x1, B y minus y1, C z minus z1 is equal to 0. What is A, B, C? A, B, C. So 1. x1 is x minus 0. 1 into y minus 1. 1 into z minus 1 is equal to 0. है ना? This is what? x1, y1, z1 and this is A, B, C. So you get x plus y minus 1 plus z minus 1 is equal to 0. So x plus y plus z is equal to 2. Which option? This option, x plus y plus z is equal to 2. That's your right answer. Simple. Next, what will be the distance of this point from this plane? We have learned the formula. The formula is distance is equal to mod value of put everything a into x1, b into y1, c into z1 plus d, right? And upon root over a square plus b square plus c square. Okay, so a is here 4. Yeah, 4 into 6, 24. 2 into 2, 4. 3 into 9, 3 9s are 27 and 46 upon root over 6 square, 2 square, 9 square. So 24 plus 4, 28. 28 minus 27, 1. 1 minus 46, 45. So this is 45. Mod value है तो not minus 45, it will be plus 45. Divide by 6 square plus 2 square plus 9 square का square root. 36 plus 4 plus 81. Right? So this is 1, 9, 10, 11, 12, 121. What is the square root of 121? 11. So this is the distance, 45 upon 11. Option number C. Got the answer simply, right? Okay, next. The sum of the intercepts made by this plane on the coordinate axis is that. How do we get the intercept? Remember, x upon a plus y upon b plus z upon z is equal to 1. So here, how do you get the intercept? I'm telling you the shortcut trick. Okay, just take the d you have here and divide it by these numbers. Okay, okay. So the sum of the intercepts will be basically 18 upon 3, 18 upon 1, 18 upon 2. Just find this. What will you get? 3 6 are 18 plus 18, 2 9 are 18. And when you add them, you get 9 3 is a 27, 27 plus 6, 33. This is your answer. Option number C. 33 is your answer. Simple. Just do this shortcut I'm telling you. How to find out intercepts. Okay. Next, the angle between the planes will be dash. How to find out the angle between planes? Theta is equal to cos inverse of A1 into A2. So this is A1, B1, C1, A2, B2, C2. So just multiply 1 into 1 plus 1 into minus 2 plus 1 into 3 upon root over 1 square, 1 square, 1 square, root over 1 square, 2 square, 3 square. So it is cos inverse of 1 minus 2 plus 3. So this is equal to 2, right? Upon root 3. And this is 3 3 is a 9, 2 2 is a 4 plus 1, 14. So square root of 14. So we get here cos inverse of 2 by root over 42. This should be the answer. Yeah, option A. Cos inverse 2 upon root over 42. Okay. Next question. What is the distance between this point and this plane? Remember distance. How to find out distance between a point and a plane? We have learned the distance formula is simply put this point in this plane. Okay. So it is basically what? A into your x1, B into y1, C into z1 plus D upon root over a1 square plus a2 square plus b1 square plus c1 square, like that. So this is A into x1. So 2 into 2, 4. 1 into 1, 1. 0 into 5, 0. Upon uh, not 5, sorry, 0 into 2, 0 plus 5 upon root over 2 square plus 1 square, right? No, 2 square plus 1 square plus 2 square. This is ABC. I am writing it here for you. This is x1, y1, z1. This is A, B, C, D. Okay. So here you get 4 plus 1, 5, 5 plus 5, 10 upon root over 2 2 is a 4 plus 1, 5 plus 4, 9, root over 9. So your answer should be 10 by 3. Right? So the distance between them is 10 by 3. Got it? Simple? Alright, so I have given you each and every type of questions that were asked in the previous year question papers of last 5 years. Now, if you practice this much, your 3D geometry is done. Khalas. Okay. Now, I have the complete formula cheat sheet and mind map for you. Just revise this before your exam and you don't need to do anything else. Okay. First is direction cosine and direction ratio relationship. Direction ratios and direction cosines for when 2 points are given. Next is direction cosines of lines when 2 points are given. Next, angle between the 2 lines formula when the lines are parallel and when the lines are perpendicular. Their formula. Then equation of a line when 1 point and 1 parallel vector is given, when 2 points are given, both in vector form. Then distance between 2 parallel lines, distance between 2 skew lines. Then we talk about plane. So this is equation of plane in when 1 point is given, equation of plane when 3 points are given. Next, distance of a point and a plane, distance between two planes formula. And lastly, if two planes intersect, then the new plane equation will be given by this, and angle between two planes will be given by this. Alright, that's all for today's class. Hope you enjoyed today's lecture, and if this was even a little useful for you, don't forget to like the video and show your love in the comment section. It gives us lots and lots of motivation to bring such videos for you, and we are trying our best and bestest to bring the world class videos for KEAM preparation, where your preparation will be minimal and our preparation will be maximum to help you in every way. So do subscribe to this channel, like the video and share with your friends. Thank you everybody. See you in the next lecture. Bye bye.